Here's a quick overview of polymerase chain reaction. The first step of PCR is denaturation. During this step, the DNA is heated up. This causes the DNA double helix to unwind and separate into two strands. The second step of PCR is annealing. When the DNA is cooled, the primers that match the ends of the DNA sequence are attached to their matching base pairs. There will be extra DNA on either side that is not part of the target sequence. It is important to make sure that the primers are on the correct sides of the DNA sequence. Otherwise, you might copy everything but the target sequence. The third and final step of PCR is extension. The DNA is heated back up. This allows the Taq polymerase to attach to the primers and begin adding new base pairs. But remember, read 3' to 5' and write 5' to 3'. The Taq polymerase begins to add the nucleotides. However, take note that in the first cycle of PCR, the Taq polymerase continues past where the selected DNA sequence ends, as indicated by the black arrows. At the end of the first cycle, the DNA has been copied into two new helices. We repeat the steps: denaturation, annealing, and extension. After the second cycle, there are now 4 new DNA helices. The red arrows show the direction and strand where the Taq polymerase added base pairs. As you can see, the top and bottom helices are the same as the original 2 copied strands. As shown by the black arrows, they continue on past the desired DNA sequence. In the middle 2 strands, the polymerase is forced to stop because the strand it is attached to ends. This is where the primer was in the cycle before. This means that the Taq polymerase can't add more nucleotides. After the second cycle, the PCR process is repeated again. After the third cycle, there are now 8 strands of DNA. Now, 2 of the strands are the correct sequence length. The PCR process is then repeated about 25 to 30 more times, and the number of DNA copies will increase exponentially. It is important to note that there will still be a few strands of DNA that are longer and extend past the desired sequence. However, there are so few compared to the billions of exact sequences that they are not likely to make an impact in further tests.